Do you want to know in how many ways you can lose the lottery? Welcome to this video about combinatorics. There are four main problems. First, depending on whether the order matters or whether repetition is allowed. Order, Reihenfolge in German, repetition, Wiederholung in German. So if the order matters, it's called permutation. If it doesn't, it's called combination. Then we see if it's permutation with Wiederholung, so with repetition, or without, so ohne Wiederholung, and combination with Wiederholung or combination without Wiederholung. And for each of them, we have different formulas. These are pretty easy to understand, but you have to remember them. And then we're gonna see first combination ohne Wiederholung because it's easier to remember and to explain. Then the second one, combination mit Wiederholung, which is a bit more tricky to understand where it comes from. First example, let's say you have a lock with 4 places, and each of these places you have 9 possibilities from 1 to 9. Your basic set for all the possibilities will be 1, 2, 3, 4, 5, etc. till 9. If you look at the number of elements in this set, there would be 9 elements, and this is your n. Does the order matter? Yes, it does, so it's a permutation. Can you use again the same number? Yes, because here you have 9 numbers, but here you can still have 9 numbers. If a 9 is taken here, the 9 can also be taken here. So you have for the first position 9 possibilities, second 9 possibilities, etc. 9 here and 9 here. So it's a permutation with repetition, mit Wiederholung, from n, which is 9, in k equals 4 places. How many for the first one? 9. How many possibilities for the second one? 9. Third, fourth. So we have 9 to the power of 4. So the general formula will be n to the power of k. Let's go on the second example. We have 6 runners. Let's call them 1 to 6. The number of runners is cardinal, die Mächtigkeit from the set J, which is n, 6 we saw. How many possibilities we have? So we are looking at the podium. So there are 3 places on the podium, and the order matters. If you are coming first, it's not the same as if you are coming third. Only one person can go on it. So how many possibilities for the first one? 6 person. Second, 5. And on the third place, only 4. This is permutation without Wiederholung. N equals 6, and there are 3 places where they could be. K equals 3. How can we make a formula out of it? Well, we see it's a bit like n factorial, because 6, 5, 4, 3, 2, 1. But we remove this part. And this part is 3 factorial, which is at least 6 minus 3 factorial. So the general formula would be n factorial divided by n minus k factorial. Here we find the second k. So let's look at the lottery. In the lottery, if you don't know, there are 49 numbers that you can pick from, and you can pick 6 numbers from them. So let's pick that one, that one, that one, that one, that one. This is a possibility, but it doesn't matter if you take this one first, or you took this one first, and then this one. So there are many cases that would result on picking the same numbers. So we have to remove them. So first, j, the number of possibilities, is the cardinal of j, which is n, which is 49. And now k, number of numbers you take each time, is 6. So we are looking for the number of combination without repetition from n equals 49 and k equals 6. How do we do? So it looks a bit like the cases we did with the runners, right? Because first there are 49 the possibilities, doesn't matter which number you take. After that there are 48, after that there are 47, etc. So it looks like factorial, but then you have to remove the number you don't take. Okay, but it's not done yet. It's not the same case. For the runners, order mattered. But here the order doesn't matter. So there are less possibilities. If you would count, we would see that there are 6 different possibilities, which are the same. So we have to divide this thing by 6 factorial. The formula will be n factorial divided by k factorial, n minus k factorial. By the way, here it's equal to this number, here it's equal to 120, and here 14 millions. So don't play Lotto, please. Let's say we have 13 kids, and we ask each kid to take 3 colors. They can choose many times the same color. For example, a kid can choose 3 times the color red. I want to know how many possibilities there are in total. We start with the same, cardinal of j equal to n, which is equal to 3. And now we have k 13. And here you see there's a problem. Because if I use the same formula, I have a problem that I have 13 to choose from 3. And n should always be greater than k. So the formula will be a bit different. The number of combination with the holung from 3, 13 is equal to 3 plus 13 minus 1 on top of 13. So n plus k minus 1 over k. That's what we have to remember. And then we have it's 15 on 13, the same as 13 over 2, which is 14, 2 times 1. And the result will be 105. So let's recap. First we had the permutation. We saw n to the power of k. Then we saw without repetition is n factorial divided by n minus k factorial. Remember that here it's a factorial and here it's to the power of. Then if we just multiply by k factorial on below, we have the combination without repetition. And then if we look that the number on top should always be bigger than the number below, we have the combination with the holung. Let's recap. Your turn. Take a blank sheet of paper, pause the video and write down all you can remember about the 4 formulas of this video. Let's recap. So we have 4 formulas with permutation, without permutation. For the permutation with repetition, so with this example that was n to the power of k. For the permutation without repetition, we saw with this example that it was n factorial divided by. Now when the order doesn't matter and the repetition is allowed, we saw it's a bit complicated, so we start with the combination without repetition, and we saw that it was the binomial coefficient from n over k. And for the combination with repetition, we saw it was a bit more complicated, but like we can remember it by remembering that the top should be bigger than bottom and should be bigger than k. So it's n plus k minus 1 over k. I took the examples of Fuchs. He made a song about combinatorics and the links is in the description. Listen to it to remember it. Now comment in the video. What is your favorite combination problem of the video? First, the lock problem. Second, the running problem. Third, the kids and colors problem. Or fourth, the lottery problem. Now you can practice. You have a PDF with exercises and solutions in the description. Please use it for the problems that you found difficult. See you in the next video.